The topic of today is biogas and bioethanol. How is bioethanol produced and how anaerobic digestion is included in the bioethanol value chain?
Ethanol is an ethyl alcohol, the same type of alcohol found in alcoholic beverages. It is most often used as a motor fuel, mainly as a biofuel additive for gasoline. So bioethanol is a form of renewable energy and is usually obtained from the conversion of carbon-based feedstock like sugarcane, sugar beet, potatoes, corn, or wheat. Processes for the production of ethanol from corn use only then a small part of the corn plant. The corn kernels are taken from the corn plant, and only the starch, which represents about 50% of the dry kernel mass, is transformed into ethanol. The other energy-rich parts of the corn plant, like protein and fat, and also the leaves and the stems, are not used. As a byproduct of the bioethanol production, there's a significant stream of energy-rich effluent that is called stillage or whole stillage. Usually this whole stillage is then processed via a centrifuge into a solid phase, which we call wet cake. It can be used as animal feed, and the liquid phase with about 5 to 10% dry matter, which we call thin stillage. All the three streams, the whole stillage, the wet cake, and the thin stillage, are still containing a lot of energy that can be converted into biogas. The biogas itself can then be used for the production of thermal and/or electrical energy, or it can be upgraded to natural gas and sold as RNG, renewable natural gas. Thermal and electrical energy can be used for covering a part of the energy consumption of the ethanol plant. So via digester treatment, a reuse of water in the ethanol plant is also possible. Finally, this combination of biogas and ethanol is a perfect match because we really can use the effluent of the ethanol plant.
The Rio Cuarto biogas plant in Argentina is a successful proven of these synergies. Can you tell us something more about this project?
Yeah, sure. For the biogas plant in Rio Cuarto, Argentina, quite the center of Argentina, which we designed about 5 years ago, we used the thin stillage as a feedstock. What I just explained is quite liquid product with 5 to 10% dry matter. In this case, in Argentina, it has about 8% of total solids, and the corn oil is still included. Very often the corn oil is removed, but in this case, it's still included. So the thin stillage, when leaving the ethanol plant, has a temperature of about 80 degrees Celsius, which is far too high for the AD process. So the first challenge is to reduce the temperature of the thin stillage. This can be done with heat recovery, which gives you then additional thermal energy that can be used in the ethanol plant. This is be done in Rio Cuarto. Also, although the thin stillage is easy to pump and has no impurities, like many other substrates for biogas plants, there are still some challenges for a stable AD process. Due to the high protein in the thin stillage and the low carbon-nitrogen ratio, we needed a relatively long adaptation time for the bacteria. Furthermore, there is a low content of trace elements in thin stillage, which requires an evaluation of optimized nutrient feeding. The AD process itself happens in a standard CSDR digester tank made of glass-coated steel. We have in Rio Cuarto one huge digester tank with 8,000 cubic meter volume, plus a secondary digester tank with gas holder membrane. So during the ethanol production, usually sulfuric acid is added for pH adjustment, which is necessary for the alcohol production. As a result, we get high H2S concentration in the biogas, which requires additional effort on desulfurization. So we had to implement an external biological trickling filter. The operations team in Rio Cuarto does a great job and is able to produce biogas with high efficiency and with a stable process. They are doing this since more than 5 years quite successfully. Plus, they established a digester treatment for water reuse in the ethanol plant, which is an additional benefit for the ethanol plant. The biogas itself is then utilized in 2 CHP units, plus in a boiler system. So the ethanol plant can replace significant amounts of natural gas, and via electricity injection, they have additional revenue.
And so, how can the integration between biogas and bioethanol production help to achieve the climate goals?
In combination with the ethanol plant, we increase the efficiency of the energy conversion. The integration of a biogas plant increases simply the output of renewable high-value energies from this organic feedstock. There is no need for additional land use to grow more crops. We simply use the effluent of the ethanol production. As I said before, bioethanol is a car fuel. Upgraded biogas can also be used as a car fuel in gaseous or liquid form as LNG, liquefied natural gas. As there are still big question marks regarding electrical heavy-duty transport for trucks, for ships, we need to use existing renewable solutions for these tasks. So bioethanol and biogas can be easily stored without efficiency losses. And compared to other renewable energies like wind and solar, the production is independent from any weather conditions. So bioethanol and biogas are part of the solutions we need for a climate-friendly future.